Hello guys and welcome. In this lecture we will see how to use geometric transformation in OpenCV and how to apply them on images. So first let me create a Python file. I will call it geometric transformation. .py. First I will import CV2 and numpy. In this lecture we will do three types of geometric transformation. We will see how to resize images and how to do translation on images and also rotation. First let's start by the resizing. I will read an image, so you can read any image you want. I will read cv2.imread and give it data the messy image. So there is two methods to read or to resize an image. The first one is to give it a new size, like for example resized image. This is resized image, and call cv2.resize, give it the image that you want to resize and give it a new width and height. So let me first give it, for example, 512. So the size of this image we can print it here, which is image.shape. This is the original size, and I want to resize it to this new size. So also can give it interpolation. Just take cv2.inter. There are many types of interpolations supported by cv2. The default one is this one, the linear, interlinear. You can test the other ones. I will use the default one, and then I will come here and show the image. cv2.imshow original image and give it the image, and also show the resized image and give it the resized image. cv2.wait key and give it 0. Come here and run the code Python and geometric transformation. So now as you can see, we have here the original image with a width of 548 and a height of 342, and this is the resized image with 512 and 512 size. We can, for example, make the image with the same scale. So if I take the width here, the height and the width from here, saying image.shape, I take just the first two elements here, and if I give them here, give 2 times this height and also 2 times this width, and let's see the image. Now let me also print its size here. So resize it, image.shape. So now this image is resized here, so I think we should put here the width and here the height to maintain the same scale. So now we have the image with width doubled and the height also doubled here, multiplied by 2. We can also resize the image using another method. For example, resize it image 2, I will call it 2, which will be use another type of resizing, or another method for resize the image, is giving image, and here instead of the giving the new width and new height, we'll give it none, but we will give it fx, which will scale the image, the horizontal or the width of the image by the scalar that we will give here. If I give, for example, 2 and give it fy also, if I give it also 2, it will make the same thing here. It will just multiply the width and height by 2. If I give it 1, it will maintain the same image, or if I give it, for example, 0.5, it will take the it will resize the image to its half. We can also specify the interpolation if you want, and let me come here and show this image, cv2.imShow, and name this window as resized method 2, for example, and call the image here. Let me show it here. We can also print the size if we want. Resize the image 2 dot shape, and just run the code. So now this is resized to the same image, as you can see here. It's the same image with the same width and height. So for translation, I can comment this resizing here because we no more need them, and I will comment them also from here. And now let's do the translation and see how it is working. So first we need to create a matrix translation. This matrix will create matrix translation. This matrix will be like that, so it will be m equals to, and this one too. So these first two ones are always 0, and here we have tx or x, and here we have 0 and 1 and y. So this 1 and 0, 0 and 1 are fixed for translation. We will change the x. If we give x as positive, it will move the image in the right, and if we give it as negative, it will move it in the left. And y here, if we give it positive, it will move the image in the bottom, and if we give it negative, it will move it up. So let's see it in practice. I will create this matrix as numpy.floats 32 and give it this matrix, so 1 0, and for x now, or tx and ty. For tx, for example, I will give it 50, and these ones are fixed, and the ty I will give it, for example, 100. And I will come here and make the transformation or the translation by saying translated, and I will call cv2.swarp_affine and give it the image, the matrix, and give it the width and height we have created here. So I will give it width and height like that, and then I will show this image here. So cv2.imShow translated, and give it the image we have created. So let's see this image now, and now we can see that OpenCV makes this translation here. If I change the value here, the tx and ty, so it will be changed. So if I, for example, make this just 20, and it will be translated a little bit here, and here is 50. Now let's move to the rotation. So I will also comment this, as I don't need them, and I will comment it from here also. So for rotation, we need also to create a rotation matrix. So to create this rotation matrix, I will call it also M, and I will use cv2.getRotationMatrix 2D, this one. This method will take the origin of the center of rotation. I will give it the center of the image, so it is width divided by 2 and height divided by 2, and then it will take also the angle that we want the image to be rotated on. So I will rotate it with 90 degree, and I will maintain the same scale of the image, so I'll give it 1. And the resulted image, I will call it rotated like that, and call cv2.warp-affine and give it the original image, this matrix, and give it the height or the width and height of this image. So the width, the same width and height of the original image. Let me come here and show this image, cv2.imShow, and call it rotated, and call the image like that, and I will show it here. So now the image is rotated with 90 degree. We can rotate it, for example, with 45. Now it is 45. If we want to rotate it with the clockwise direction, we can give it negative, for example, minus 90 degree. So now it is rotated in the other direction. We can also flip it horizontally by giving here 180. So now it is flipped like that, as you can see.